In this presentation, we're going to look at a second order ODE problem again. So what we're going to do here is find the function f of x that satisfies the following equation here. So this is the equation we're going to work with. D squared f over dx squared is equal to minus df dx plus 12f minus 12x minus 11. We're also given some initial values there. F of 0 equals 2 and the f dash of 0 is equal to 11. That's the derivative. In other words, df dx when x is 0. Just in case you're not familiar with, expect both types of notation actually. What I'm going to do here first off is I'm going to go back to this equation here up at the top and I'm going to rephrase it. I'm going to slightly restructure it such that I have all the f terms on one side. Okay, so what I'm going to do here is bring all the f terms the other side. If you have it written down, you'll sort of see what I mean. That I have minus df dx, so I'm going to bring it over the other side of the equation. So I have df dx, and I had plus 12, so now it's minus 12 when I bring it over to this side. So you can just check that with your notes there, or pause and just go back for a second and just check. Is this the right equation? Is it the same equation? It's just I've ordered everything on one side of the line. Okay. Or all the f terms on one side of the equal sign. Okay. Now, so the first step is to take this part here and use it to construct what they call the auxiliary equation. Okay. So this is the sort of general structure of it here. As I'm just going to put in my coefficients there. So what we had is df d squared f over dx squared plus df dx, okay, minus 12f. So there's a minus 12f there. It generally follows that sort of same general form. So just write it out like that. Now the auxiliary equation, I tend to write it out in z, but somebody just sort of said, well, some people use m. Okay, well, I'll just keep using z, but sometimes people write this auxiliary equation in terms of m rather than z. You solve it the same way, so it doesn't really matter. What we have this is the auxiliary equation specifically, and it's a polynomial, it's a quadratic equation, so it should have two distinct roots. Not if it has complex roots or the same root, there's something you can do, but this one will actually work out to be nice and easy. It actually works out to be x plus 4, sorry, z plus 4, z minus 3 equals 0. So the roots are minus 4 and 3. Okay, so nice two distinct roots there. What we're going to do is use them in the... I'm going to sort of save them for a while. Okay, that's a sort of big step taken there, but I'm going to sort of save that for a while. What I'm going to do now is do a thing called the particular solution. Okay, now if you recall, we have this stuff over here. That's a polynomial of degree 1. Okay, the highest power is x. Okay, so what I'm going to do here is set up a particular solution with these undetermined coefficients. So it's because it's minus 12x minus 11. Okay, it just happens to have the same form. So what I'm going to do is get the derivative of ax plus b. So essentially what we have to do is find out what a is and find out what b is. Okay, and so we get the derivative of f and the second of f with respect to x, the derivative of f with respect to x and the second derivative of f with respect to x, a and 0 respectively. Okay, and what we're going to do is put these values into our equation here. So what we have here is, I'm going to put this in black for a second, 0 plus a minus 12 times ax plus b. Okay, and that is going to equal minus 12x minus 11. Okay, probably should have spaced it out a bit more here, but I'll do that again. A minus 12ax minus 12b is equal to minus 12x minus 11. Okay, so let's just sort of regroup the terms there. I'm going to put this back in blue now. So minus 12ax minus 12b minus a. I'm going to put that second term there like that. So it's a double negative. Okay. You can just check that yourself by reversing what I have there. That's equal to minus 12x minus 11. Now clearly you can tell here that small a is going to equal to 1. Okay, because I'm comparing this term here with this term here. And I'm going to compare this term here with this term here. Okay, so a is going to equal to 1. Minus 12ax equals to minus 12x. Okay, so a has to equal 1. B is going to... So what we have here is 12b minus 1 equals 11. Okay, now just be careful. I'm not including the sign on either side. Okay. So it's the minus signs here are not being are not necessary for inclusion the way I've written it, but just be careful of that, those signs. Okay. So 12. Okay, so 12b. So necessarily, b is going to equal to 1 also. B is equal to 1 also. Okay, so what does that mean? Essentially, our particular solution, f of x, is essentially ax plus b. That's equal to x plus 1. Okay, so that's part of our overall solution. That part there. Okay. So we're going to sort of use this result later on. Particularly this bit here. We're going to use it later on. We're just going to get the complementary solution now. Now this one was quite easy. Earlier on we decided that z was either minus 4 or 3. So essentially this is the complementary solution. We have these undetermined coefficients there. Essentially our solutions to the auxiliary equation, we just put them in there. That minus 4 there and that 3 there. And we have these undetermined coefficients, capital A, capital B. We put that in as powers of minus 4x, e to the minus 4x and stuff like that. That's just the sort of general strategy for solving these complementary or these ODE questions. Okay, so that's that part there. So we're going to put that together. That part is quite simple. There we have it there. That's actually gone a bit too far there. There's this sort of that's actually from the last one I've done. So I'm just going to fix it up a bit. So minus 4x, and there we go. B times e to the 3x. I'll just check I have that right. Yep, okay, so we're good to go. Now, so far so good. What we know is that at f0 is equal to 2. This is what we were told earlier on. F of 0 is equal to 2. So 0 plus 1 plus a times e to the 0. Okay, e to the 0 plus b times e to the 0. That's equal to 2. Now e to the 0 is simply 1. So that can cancel out, that can cancel out. Essentially what we're left is 1 plus a plus b is equal to 2. And so far so good. And then what we're told is that f, just going to get rid of some stuff there, f dash of x is equal to 11 when this is equal to 0, when x is equal to 0. So what we got to do here is got a little bit of work ahead of us now. What we got to do is get the derivative of those there. Okay, so derivative of x is 1 plus 0, okay, minus 4 times a e to the minus 4x plus 3b e to the 3x. Okay, simple derivatives there. Okay, and when that's 0, what do we get? 1 minus 4 times a plus 3 times b. And again, e to the 0 cancels out. Okay. And that's equal to 11. Okay. So what we have here is two equations, two unknowns. Let's just sort of group them up. A plus b plus 1 is equal to 2. Minus 4a plus 3b plus 1 is equal to 11. Okay. Now, you could sort of go about solving that, but for the sake of brevity, I'm just going to state that a is equal to minus 1 and b is equal to 2. Okay, so that you can sort of, it's a straightforward enough calculation there to do that. And yep. So what we're going to sort of end up with saying is that our solution here is as follows. A is equal to minus 1, so plus a becomes minus 1. And b is 2, so b becomes 2. So this is our overall solution down here. F of x equals x plus 1, the particular solution, and the complementary solution. There we go. And that is it.